So let's talk about the questions and the conclusions from our atmospheric moisture lab number 3. Here's what you need to do in order to receive a done stamp on this assignment when I see you next. First of all, you have to have completed the math for this chart. You have had to have done the math to figure out the percent full that the sponge was with each teaspoon that you added. And that was based on, well, how many teaspoons did it take to fill the sponge up? You have the formula. You take 1 teaspoon divided by how many total it took to fill it up, times it by 100, and that gets you the percent full. And you go through this up to the number of teaspoons that it took to fill the sponge up, because that would be 100%. It's all full. In addition, you have to answer these questions as I explain them to you. If you have already answered these, that's fine. It's great. But when I check this on Monday, I'm not going to give you a done stamp if you don't have the correct understanding shown here. So if you've already answered these, listen to what I'm explaining here. And if you have that same understanding shown, that's fine. You don't have to change anything. But if you have something else written there, you need to either change it, or if you wrote in pen, write it on a separate page in your notebook to be able to show me on Monday that you understand what this activity was meant to show you. So getting right into it. Was this activity demonstrating humidity or relative humidity? And it says explain. You've got to get the explanation. That shows me that you understand the difference between relative and just plain humidity. Well, that was a trick question. The answer there for number 1 is actually both. This lab showed both humidity and relative humidity. Let's explain. You must explain on that paper in order to get your done stamp and your credit for doing this assignment. So how does this show humidity? Remember that humidity is the amount of water in the air, or in this case, let's say the amount of water in our sponge. Well, how much water did you put in your sponge? You took 1 teaspoon and you put it on the sponge. That's an amount of water in the sponge. Well, then you took a 2nd teaspoon of water. Well, that's a different amount of water that's in the sponge. That's representative of humidity. So how did this show you humidity? It showed humidity because we actually measured the amount of water going in. It was 1 teaspoon, 2 teaspoons, 3 teaspoons. That's like humidity. The amount of teaspoons represents the humidity, or how much water was actually in there. Now, relative humidity is a little bit different. Relative humidity is how full the thing is, mostly air, but in this case a sponge. How full is it with water? Obviously 100% is all the way full. I've put 2 teaspoons in here already. My sponge is not yet full. I can see it's still got dry areas on it. It can hold more water, so it is not 100% full yet. So let's make up a number. Let's say that this sponge can hold max 10 teaspoons, and I've put in 2 teaspoons already. Well, that means 2 out of 10, it's 20% full. That's relative humidity. Relative humidity is how full something is with water. How did this lab or this activity demonstrate relative humidity? Because we calculated the percent full it is, and that is what relative humidity is. So this lab activity showed us both, and hopefully it gives you an understanding of the difference between what humidity is versus relative humidity. Now, that second question, what does it mean to be saturated? Saturated means that you're full. You can't hold any more. How does this activity demonstrate saturation? Well, we put water into the sponge until we couldn't fit any more. That's what saturation is. We figured out the point at which the sponge could not hold any more water, and that is saturation. Now, if the 2 sponges, we used a big sponge and we used a small sponge, and let's say that these represent samples of air. Well, what would be the difference between this air and this air in terms of size? Well, the difference would be their temperatures. The large sponge would represent warmer air, and the smaller sponge would represent colder air, because we know this to be true. We know that hot air can hold more water than cold air. Now, what did the extension activity represent? Some of you did not get in the time to do the extension activity, and that's fine. So here's what we had. We had our sponge, we had our small sponge, a dry small sponge, and I had my original big wet sponge. And I said, put the water back into the small sponge through a funnel. Doing like this. And I'm going to try to squeeze the water from the big sponge, and you'll notice there it's coming out the bottom. My small sponge couldn't hold the water from my big sponge. Well, remember, what's the difference between the big sponge and the small sponge is temperature. So this is hot air and this is colder air. Well, this might be air during the day when the sun's out and it's warm and it's able to hold a lot of water, and it does. Then the sun goes down, and what happens to my air is that it gets smaller. It can't hold as much water because it's now cold outside because the sun's gone down, and you see, it can't hold the water anymore. This is meant to represent dew, or how dew is formed. When you've got warmer air that can't hold its water anymore, because my daytime air turns into a smaller sponge at night, and it can't hold as much water. So what it does is it drops it on the ground. So the extension activity was meant to give you a kind of a visual representation of how dew actually forms. So at this time, make sure you have all of that on your paper, glue it in your notebook, show it to me on Monday, and you'll get credit for doing this assignment.